Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, or if you're on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that. It'll allow you to type in your question, hit submit, and I'll get to those at the end of the session. If you're watching on YouTube, just feel free to use the live chat function that's in there wherever it happens to be on your screen. Just type in your question to the chat, and I'll get to those at the end of the session as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep at Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. And before that, it was 8 years at Subaru. So worked at a dealership, and over time, I guess, became the go-to diag guy in the shop, right? So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out any of those weird head scratcher type cars that would come into my bay. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. And tonight, our topic is forced inductions. We're going to get boosted here. So forced induction overview and diagnosis. Now, why are we talking about turbos and superchargers and things like that? Well, because if you haven't noticed in the last 10 years or so, 10, 12 years, according to this chart, there has just been this explosion in turbocharged vehicles out there as part of the the normal car park. And I actually read an article today that the average age of a vehicle coming into a shop now is 12 years. So that would bring us back to 2010 for a 12-year-old car. Of course, there's some that are older, and of course, there's a ton that are newer, but the average age for a car going in the shop is 2010. So anything newer than that, that's really seems to be that cutoff line right there. So this is based on U.S. government data, vehicles on the road, and it goes up to 2019 model year, but you can see just how it took off in the last 10 years or so. It was quite a jump from 2010 to 11 and 12, and then 13 it went way up. And we're over 35% of the market has turbochargers on there now. So we think we see car on the bottom, car, SUV. I guess that'd be more like a crossover. Vans only got a teeny tiny little sliver in there, but I would say that'd be anything with a diesel. All right, any light duty van with a diesel. Truck, SUV, and of course your pick 'em up trucks too, because, well, a lot of pickup trucks out there are diesel vehicles, so that is a good proportion of it there as well. So just a huge explosion over the last few years. And really, I looked through Shopkey for, I think it was around 2020 model year. Every single manufacturer that we covered for that model year has a turbocharged model of some sort. Some of the vehicles, that's all they have is turbo models. Some they have just a turbo option for one of the engines, for example, like Ford with their EcoBoost. Subaru, as I said, I worked there for a while, and what it was is once the turbos came out, there was a naturally aspirated version, and there was a turbo version of all their models. And I think it's pretty well the same thing now, except for the Ascent that didn't get a turbo, I don't think. But I have a Forester, had a Forester non-turbo, and then there's also a Forester turbo, and so on and so forth. So, GMC, any of their, they have turbocharged V6s, and they also have any of their diesel engines. Every single one of these manufacturers that's covered has a turbocharger in it, or forced induction, I guess. Really, we don't see a lot of superchargers anymore. We see a lot more turbochargers than anything. And I think it's pretty much across the board. Everybody's got this on a turbocharger now. There could be one or two superchargers out there, but it's really not as common as before. So why did they go to forced induction? And why did they go to forced induction roundabout the times that they did? If you think back to that chart, well, there were certain miles per gallon thresholds that needed to be met. So they can get more power out of a smaller engine. So smaller engine is going to take less fuel, but I want to be able to get the same amount of power that I could have had before on a larger engine. So you can get more power out of that smaller engine by compressing the air charge. Also, with the more air, we can have a little bit less fuel as well, which can lean out the mixture, and that gives us better miles per gallon there as well. It's especially true on a diesel where They don't really care about running too lean because that's pretty much how they ignite anyway. So here's just a breakdown of a basic turbocharged gasoline engine. So, it goes through the air filter, goes into the compressor side of the turbo. The compressor side is driven. There's a shaft that goes across to the turbine side, which runs off the exhaust gases. So the exhaust pressure turns this turbine, spins the compressor, the air comes in, it gets compressed in through this boost pipe, through the intercooler to cool off the charge, through the charge pipe, through the throttle, in through the intake manifold, and it gets burned and then back out to the exhaust manifold. And then it has other parts that we're going to talk about here as well. It goes down the dump pipe. We also have the wastegate, boost control, and the blow-off valve in there as well. So all of those are kind of necessary. And as it says, the diesel, this was a diesel. It's going to be set up the same way. It just wouldn't have the throttle plate right there. So diesel is going to work the same way. Turbo is going to work the same way when we talk about it. So forced induction components. This is what we're going to talk about this evening. So we have superchargers, turbochargers, variable geometry turbochargers are part of that. And there's an actuator that goes along with that. Wastegate, boost controller, blow-off valve, or recirc valve, depending on how the manufacturer has it set up, and then the intercooler as well. So we'll talk about all these different items. So first up is our supercharger. It is a belt-driven air compressor. If you want to get down to its most basic level, it is a belt-driven air compressor. That's what all of these things are, just air compressors. This is a belt-driven air compressor. There are different types out there. There's 3 different types that you'll see out there. It's going to be a screw type, a scroll type, and a centrifugal type. It uses the engine power to drive, since it is running off a belt, right? So it may have its own belt, or it runs off the accessory belt with everything else on the vehicle. Due to that, though, it does end up being a parasitic load on the engine. So it does reduce the power output over what something like a turbo might give, because we have to use a little bit of that power we're generating to turn the supercharger. So it's kind of like a perpetual need that energy to turn it. So first type, the screw type, is going to be this roots type supercharger here. And this is a nifty little 3D animation of that. So air comes in one side, and then as it gets in through, compressed through these screws, as it goes down, it gets progressively smaller and smaller and smaller. So you have the same amount of air in a smaller space, so the pressure increases. And that's how that works. So it's so they're intertwined. As you can see, those lobes are intertwined, and also the passages get a bit smaller as it goes through, and it squirts out the other end. So it's compressing. Next, we have a scroll type supercharger, which works on the same, I guess, basic idea as that. So if my air were to come in over here, air comes in and it gets routed through here, sped up, and then it also gets pushed into a smaller and smaller spiral into a smaller and smaller space. And then in the middle, that's where my outlet is. So that's just another way that they do it. So the air will go in and it just gets compressed smaller and smaller as it goes down, and it gets put out the middle. So it does that by having one plate is stationary, the other plate rotates around. And then we have a centrifugal supercharger. So you may have seen these a lot of times aftermarket. They'll have these centrifugal supercharger. And basically what this is a turbocharger with the compressor side, but the side that would be driven by the exhaust is actually driven by a belt. So it works the same as a supercharger. We have bearings. We have the impeller in here. So the air comes in here, gets compressed as it goes around the snail shell, and then it gets output at a higher speed. So we have the belt drive here with gears, reduction gears in there. Also has an oil pump in there for the the gearing and whatnot, so it doesn't seize up. We'll have oil in there. So I know that this used to be big in the aftermarket. You can buy the kits, centrifugal supercharger kits out there. Volkswagen was really the only one that I was able to find that used one of these in production. Other than that, they were usually the roots type or the scroll type. So let's take a little look. This was an interesting little case study we had with an 06 Mini Cooper S. S means supercharged in this case. And the customer complaint was lack of power and a weird noise coming from the front of the vehicle, and the engine lights. So of course, first thing you want to do is you want to pull up the scan tool and do a full vehicle code scan. You go through there and found a P1688 code. So the definition of this code, if we look, says electronic throttle control monitor level 2.3 mass airflow calculation. So just at first glance, you may think, oh, it must be maybe something wrong with the mass airflow sensor. Maybe there's a problem with the duct work or something like that, metered air problem. Since we're on a Zeus right here, we can hit diagnose, go into fast track intelligent diagnostics, take a look at what we have there. So a nice thing that fast track intelligent diagnostics does for us, if you have a tool that has that capability, is it takes all the different information you might need to repair the vehicle and puts it all in one central location. It also allows you to have a repeatable diagnostic workflow if you use this. So if you read it like a book, top to bottom, left to right, go through each of these things, you will find you'll go through TSBs first, and then you go through top repairs, and then smart data, and so on and so forth. Brings you through a repeatable workflow. That way you don't skip any steps. And the first thing we want to do anytime we're diagnosing a vehicle is we're going to want to go through TSBs and check. So it looks like it pulled up 2 TSBs out of the hundreds of possible TSBs there could be on this vehicle. There's 2 different TSBs here. So we have a fault here and then a diagnostic hint here. So first one's a fault. So this is pertaining to the W11 engine, which would be the supercharged engine back then. Customer complains of lack of power. We got that. Engine's in fail-safe mode. Got that. Service engine soon light is illuminated. Fault code P1688. Yep, sounds like correct. Can be caused by a possible air leak in the induction system. Map sensors are indicating implausible values, or failure of the supercharger bypass valve is sticking. So we scroll down a little bit further and look at the procedure. Check the complete air intake system, including throttle body, supercharger, intercooler, and inlet manifold for air leaks. If no problem is found, verify both the manifold pressure sensors show plausible values. If the values are not plausible, refer to the map sensor test module. If the values are plausible, replace the supercharger bypass valve and reprogram the engine computer. And then it gives you a road test and on how to verify your repair down here at the bottom. So according to them, according to Mini or BMW, I guess it would be, but if there's no air leaks and the sensors are okay, it's got to be this bypass. Look at the other one. Let's see. Lack of power, fail-safe mode, P1688 code, good. Possible failure of the supercharger bypass valve again. And this says when performing a DIS GT1 test module after fault P1688 is stored, in most cases, the test plan incorrectly directs the technician to replacement of the DME control module. So if you were to follow the test plan on the factory tool for this code, it will direct you to replace the computer. When diagnosing a Cooper S with this fault, inspect the proper operation of the bypass valve in the air intake system using a handheld vacuum pump. Activate bypass valve and observe its operation. Valve is sticking in a position, replace it with a new part. And so that says if it's sticking. Otherwise, the other bulletin said replace it. Now, if I come over here, though, and you may have noticed this a little bit earlier if you were looking at this graph when I had the screen up before. Number 1 repair for this problem, overwhelmingly so. If we look at this top repairs graph. Overwhelmingly so, the number 1 repair is replace the harmonic balancer. 188 times over this 200,000 mile range. So what the 188 is that adding up all of these different data points on that one line on the graph gives us 188 times. Looks like the number 1 most common time was around 100,000 miles, and 65 times that repair was noted at 100,000, and so on and so forth. You can see how it kind of tails off and then tails off. So we got harmonic balancers number 1, crankshaft bolts number 2, because for replacing the harmonic balancer, that may be part of the repair. Drive belt tensioner could be. 11 times replace the supercharger, and 1 time replace the fuel filter. So 1 person replaced the fuel filter for this code, and not sure if that quite may have fixed the problem. What this does is it pulls the repairs off the repair order. So if it was on the repair order at the same time as any of the other stuff, maybe it's getting maintenance done, right? So number 1 says harmonic balancer. That's a little curious. So go down a little bit further, and we get to our real fixes, our SureTrack information, which is real-world information pulled out of real-world repair orders, over 2 billion repair orders, and it says 51 times has fixed the problem. Customer states the engine lights on, the vehicle lacks power. Confirm the customer's complaint, found a vehicle lacked power and acceleration. Connected scan tool, found P1688. At idle, back probe the mass airflow sensor, monitor the sensor on a lab scope. Mass airflow sensor observed on the scope was within specs. So that says test here for plausible reading. Performed a second road test of the vehicle, heard a slight metallic noise from the front of the vehicle and smelled a burning rubber odor. Hoisted the vehicle, inspected the front of the vehicle, and noticed the crankshaft pulley had separated from the harmonic balancer. The crankshaft pulley is integrated in the harmonic balancer as replaced as an entire unit. The damaged crankshaft pulley caused the digital electronics module to miscalculate the vehicle's engine speed. Therefore, the DME miscalculated the engine load and set the trouble code. So basically, it's expecting a certain amount of airflow, a certain amount of load at a certain engine speed. When my harmonic balancer separates like that, the engine is not able to turn the supercharger at the speed that it needs to get the volume of air into the vehicle. So that was the problem. Replaced the harmonic balancer, clear the codes, and everything was fine. So as we saw, this is number one repair a lot of times. I've talked to people, I've told this story out on the road, do classes and such, and they're like, oh yeah, I've seen a couple of those. One of them was like, hey, my buddy's car had that problem last week. I've seen it. So if we go into shop key information as well, take a look and see what we have. We got a lot of information on that as well. But if we go into the parts and labor guide, though, we can see the vibration damper, $406, and it takes 1.9 hours, or pays 1.9 hours. Now, the other thing about this, you might think, well, wouldn't you have some other symptoms, other weird problems with this car? But if you've ever looked under the hood on a Mini, there's not a lot of room next to that engine, between the engine and the side of the frame or unibody or whatever. There's not a lot of room. So when that thing breaks, it doesn't have very far to go. It's just, you might hear metallic noise because it's rubbing it on it and whatever. But $400 and 2 hours. Now, if you were to go and replace the electronic control module, which, as it said, the test plan erroneously tells you to do this sometimes, $1,500 for a new computer and plus flashing it and an hour labor. If you needed to go replace a supercharger, if you thought there was a problem with the supercharger, brand new one's $4,400, reman one's $1,100. So that, and it looks like it takes about 6 hours to get to, because hey, that's way in the back of the engine from what I recall. So not necessarily something you'd want to do just guessing. So having that information, I think, was key. And then there's an example, I just found one on the internet of a separated mini harmonic balancer, and you can see how it's got the metal on the inside, metal on the outside, and then we got the rubber in between. The rubber separates from where it was attached, and that's when we had this problem. So that was an interesting supercharger related, supercharger adjacent problem. So they might have thought it was a supercharger, but it ended up being fully kind of interesting. All right, so now let's get to turbos. As we said, all of these things are air compressors. So it is an exhaust-driven air compressor in this case, not a belt-driven air compressor. There are a couple different types. We have single and twin scroll, and then we also have a variable geometry turbo as well. And he uses the exhaust gases to drive it. The con with that aspect is it causes turbo lag. So it takes a little while to get those exhaust gases flowing fast enough to get the spin fast enough. So you might not have boost up until a little bit later on in your acceleration. The twin scroll design, which not a lot of manufacturers use, but in the event that it does, that helps it spool up a little bit faster because it has a smaller and then a larger inlet that it uses, and allows it to spin it up faster at a lower RPM. And variable geometry kind of takes care of that. So we got the turbocharger here, and as we saw earlier, and we'll see this again in a minute, we got our compressor side here, which would be the inlet. Air comes in on the side here, and then it goes through this little snail shell looking thing, and then it goes out towards the intake or the intercooler that way. And this is the exhaust side. So the exhaust comes in the bottom, it spins it around, and then it goes out the back in this case. We also have our wastegate and wastegate actuator, vacuum actuator. We'll talk about all these things in a few minutes. This one also uses coolant to cool it. So it's got a coolant pipe here on the side, and then it also has oil as well for the shaft lubricant. So there's an oil passage that goes through there as well on this particular turbo. So as we saw before, the airflow, so it goes through the air filter, through the compressor, in through the boost pipe, in through the intercooler, back through the charge pipe, intake manifold, and then the exhaust turns it, and then they are attached with this shaft right here. And of course, it goes back down out the exhaust and back out the muffler in that case. Variable geometry turbo, what this does is it helps the turbo spool up faster by changing the amount of exhaust gas going through there. So we're going to have a small amount of exhaust gas at the beginning spinning the turbine, so it lessens the size of the passages to allow it to spin up faster. Once it gets going, it can open up the passages, allows more exhaust flow in there, and allows it to spool up as normal. So these little fins just kind of move back and forth. There's an actuator that does this. Could be vacuum actuated or electronically actuated. We'll see in a little bit. But there's my diaphragm there, and then there's a little arm that pushes on a circle, and they're cammed together, so they open and they close. So if we look here, there's an animation of that, what that would look like. So the actuator would push the outside, open or close, and then it makes them smaller or larger, these passages in here. And of course, there'd be a cover over that, and that changes the amount of airflow going into the turbine. Now, what problems can we have with a turbocharger? Well, the main issues you're going to see usually, because it's mostly mechanical, a supercharger or turbocharger is mostly mechanical. You might have a couple electronic actuators on there, as we'll see in a minute, but it's generally mechanical. So generally what you're going to see is a mechanical failure. And in this case, we have probably one of the more common mechanical failures, and that usually is led from lack of maintenance. So couldn't tell you how many times I replaced the turbo on a Subaru when I was at the dealership. And that was fairly early on in their turbocharging days in the States anyway. But what would happen inevitably is, customers would drive their cars and they don't maintain the oil right. And this ended up being the last thing that get fed too, which was, I think, maybe an engineering issue. But when they don't get fed, or if they get fed with contaminated oil, these things are spinning 20, 30, 40, 50,000 RPM, depending on the vehicle, and get pretty hot, and they definitely need that lubricant. So once they stop getting lubricated, gets very, very hot, and then shaft breaks oftentimes. So when the shaft breaks, the two pieces separate from each other, and they're just able to kind of rattle around. So that's why we get this damage, spinning at 20, 30, 40,000 RPM. And then when it separates and comes apart, it's just horrible noise. Makes a horrible rattling noise. And generally, they're larger diameter than the hole that they're in, too. So it's not like they go flying out. They're just kind of sitting there and they rattle around with the shaft. So it makes a really loud noise, and you get a lack of power. And says, oh, my car just died on me. Yeah, well, you haven't changed your oil in like 20,000 miles either. So that's probably why. Lack of oil pressure, lack of maintenance, big cause for issues there. Of course, we could have other external problems as well. But in my experience, anyways, that is one of the most common problems, is they will break. Wastegate. So wastegate solenoid. In this case, it is a vacuum operated wastegate. And what that does is it moves the shaft in and out. We saw that a little bit earlier. And it bleeds off some of the pressure going into the exhaust side, which slows down the turbo, which in turn lowers the boost pressure. So on the vacuum actuated one, once it gets to a certain boost level, it's going to push that open, and it's going to open that arm, which is up here. And it's going to open this little flapper door, and it lets some of that exhaust gas bleed off, which once again slows down the turbo and then decreases the amount of pressure. So it's kind of able to regulate the pressure inside. Also on some vehicles, we have found, Hyundais for sure are a big fan of this. They also have electronically motor actuated wastegates. So in this case, we got the rod right there. We still got the wastegate on the back, but this is a DC motor and with a cam, and it just kind of moves it open and closed as it turns. So that's just another way of doing that. We can see there's the cam up there on top. We got the bolt where the rod goes, and then it comes down into the motor shaft, which is down here. There's a reduction gear in there as well. And that's an electronic component, so that can be tested electrically, functional tests to open and close it, and so on. Then we have boost control. So ECMs generally nowadays anyways, there are some manual vacuum types, usually a lot of times aftermarket ones. But there is an ECM controlled solenoid that regulates the boost pressure as well, uses the vacuum and boost to open the wastegate. So this is off to the side maybe, or attached some other way, and it actuates the wastegate. Sometimes can also be called a wastegate control solenoid. So you may have seen that before with that. So a boost controller or a wastegate control solenoid. Then we have the blow off or recirc valve, depending on how the manufacturer has it set up. So it is vacuum operated again, and this works on the other side. So instead of working on the exhaust side like the wastegate, this works on the intake side. So if I'm boosting, I'm driving on down the road and I need to shift, I got to lift my foot off the throttle. What happens to the throttle plate? Throttle plate closes. But I got a bunch of boosted air in there. It's going to run into that throttle body, and if it gets back into the turbo, that can cause damage. So instead, what they do is, as soon as that happens, it sees the spike in boost pressure, And then we have it's vacuum operated. And as soon as that happens, it opens up, opens the gate. And then that excess boosted air goes out to either the atmosphere, or in some vehicles, it'll reroute back into the intake again. So you don't lose that metered air. That's how Subaru does it. But a lot of times, if you ever heard a turbocharged vehicle, the first thing, that's usually the first mod that people do on those is so you hear the psh noise anytime they shift. So that is when the throttle closes, that's what happens. Some aftermarket units vent to the atmosphere. Some OEM ones do as well. It just depends on whether they have that air metered or not. And then we have the intercooler. So what the intercooler does is, well, if we compress air, it increases the temperature. Now, hot air is not ideal for burning with fuel. So we want cooler air because cooler air is a little more dense. The intercooler is used to cool that compressed air charge. So it comes in hot on one side, comes out cool on the other side. Can be air to air or air to water type as well. So generally, they're going to be air to air, and they'll just use ambient air, fan to cool it off. But there are some that are air to water, which cool with coolant. And then there's other ones, like I remember the first iteration of the STI over here in North America had a little water nozzle that would spray. There's a little tank in the back. You put the still water in there, and then it had a little button, and you would spray it, and it would actually help cool off the charge. So a couple different ways of doing it. Manufacturers do it a bunch of different ways. Interesting enough, yesterday I found a video popped up in my feed. It was from this channel on YouTube, Warp Perception. He does a lot of these type of automotive high-speed camera things and so on. So he actually built an intercooler with clear tanks on either side. So he took the center part and he made some plexiglass tanks for either side, and actually had a smoke machine. So you could suck in the smoke machine air in through it, and you could see how it flowed through. He actually measured the temperature going in and out as well. Pretty cool. He did 2 videos on that. So if you're interested and you're watching on YouTube, wait till my video's done, and then you can go watch him. So that's Warp Perception, I said, was the channel there. So yeah, pretty cool stuff over there. And you can take a better look at how that works. All right, so let's look on the tool and see a couple things we could see. So I picked a fairly common vehicle. It's 2018 Hyundai Santa Fe Sport with a 2.0 liter turbo. Hyundai, Kia, they're very big on turbocharging for this. So let's go look in my repair information, which is not this vehicle. I don't know why that ended up. Let's see. So we'll reactivate this again. I don't know how that ended up. That was an electric vehicle. Okay. There we go. All right. So based on 28,738 real world repair orders. Interestingly enough, the number 1 and number 2 codes for this vehicle, number of repairs, 88 times and 53 times, were turbo related. So turbocharger boost control position sensor A circuit and turbocharger boost control position sensor A circuit high. So the boost controller in this case is that electric one I was showing you a little bit earlier. It's an electronically operated boost controller. So let's take a little bit better look at that. I can go in here. I got my code there, or I got my code with related issue. So in this case, we'll look at the turbocharger wastegate actuator, because that was a top fix. So you have real fixes, top repairs, causes and fixes, specs. Let's go into OEM testing. And let's see. First thing it's going to give us is a nice picture of where it is. So it's located on the turbo there. We can see the rod. We can see the motor. Looks like it is way down in the back, though, so probably not that easy to get to. So it might take a little while to get there. Might have to remove some stuff. And then it tells us what the DTC strategy is for it and how we would go through. We want to check the voltage and the current going to that motor. We can check the resistance on it as well. We also want you to use data from PID data to see turbocharger boost pressure and so on. The diagnosis problem, and then we can go down a little bit further. Could be poor harness, poor electrical connectors. Seems like they have a fairly decent problem with these, because those are the top 2 codes on this vehicle. There's another locator for it. And there's another one I want to see right here. All right, so supply voltage angle. So we can do supply voltage versus angle. So if we have 4.2 volts, it is closed. And if we have half a volt, it's at 90 degrees, it should be. So that'd be full open. So closed, open, and full open goes anywhere from 4.2 volts to half a volt, depending on which way we go. So that's just kind of interesting. They give you a little chart, plus the visual to see if you're able to take a look at it. And then once again, just a different view of that wastegate valve right there. Right? So they give you a lot of information. Now let's see how this would be wired up. Let's go to the wiring diagrams here. And I'm going to open my wastegate actuator on the 2-liter turbo. And there's my wastegate actuator. All the wires are highlighted, so I'll just dim the other ones. And we will get in a little bit closer and see where those wires go. So here's the wastegate actuator. Remember how it said it had the motor and it also had a position sensor. So the motor, we got a plus and minus on the DC motor, so we can open it and close it. And then we have a sensor signal there, which would be the middle. So that's going to be essentially like a throttle position sensor. It's going to work in the same way. It's going to vary the amount of voltage coming back out through here. We got a 5-volt feed and a ground. And then it just, depending on the resistance where it's at, it is going to send a position sensor signal back to the computer in that way. So good to know. Good to know. Let me see. I wanted to actually take a look at that actuator. Let's take a look at that. I want to see how much that thing costs. Actually, I don't think it's going to tell us what it costs because it's integral with the turbo, but we can find out how much the turbo is. So let's see. Superchargers, wastegate actuator, remove and replace. So our labor time anyways is 0.8. Apparently it's not that hard to get to. But let's look in here again under turbochargers and turbocharger itself. $1,400. $1,400, 1.9 hours to remove and replace that turbocharger. So I guess it's in the back, but it must be easy enough to get to. It only takes 2 hours to replace. So that's way faster than you would get for a Subaru one for sure. So actually the newer ones are pretty easy because they're on the bottom, but the old ones at the top, those are not that easy. So yeah, $1,400, 2 hours to do if the wastegate actuator fails, you have to buy an integral with the turbo. So that kind of stinks, but a lot of manufacturers are like that. All right, let's look at guided component tests. A couple different things we can look in there. So we'll go into engine and then look under the turbo recirculation valve. They have it's a recirculation valve. We also have the wastegate valve there. So we go into component information. We already saw, it's DC motor, which actuates a wastegated 2-step gear, which increases torque of the DC motor, and a position sensor. And if we look over, here's the pinout. Here's my positive, here my negative, my signal, my ground, and my 5 volts for the PCM. So we can see where we test it right there. It doesn't give you a specific voltage test, but at least you can look here and see where the voltage would be. So you can check for reference voltage as well. In this case, we have a resistance test though. And it says should be 1.44 to 1.96 ohms at 68 degrees Fahrenheit between terminal 1 and terminal 3. So we put our 2 pins there, and then we'd measure and see what is my motor resistance. If it's too high, then it's bad. If it's open, it's bad. Also in the guided component tests, if I don't have a vehicle ID in here, we do have the classes built in. And if I go into how to, down here somewhere, there we go, 15-minute forced induction system. So there's a wealth of information in here. It talks about some of the things I talked about tonight, goes in a little more detail if you want. Basic reasons for forced induction, turbocharger, supercharger are in there. So it gives us a couple different examples of why you may or may not want to use it. There's our screw types, and then so on and so forth. It gives you a whole bunch of information as to what you can learn about that. So that's all in under the classes and guided component test. One more thing, let's take a look at the scanner information on that. So I reload the vehicle. So they did say to go look at data, but we also can go in here under engine, and there should be some system tests as well. Actually, no, it's not system tests, it is functional tests. There we go. So you see a ton of functional tests on this vehicle, enable injectors and coils and oxygen sensor heaters and stuff. We have a turbocharger bypass valve. And then we also have the electronic wastegate valve. So that's what we were talking about before. Key on, engine off, of course. And then this is a start stop. So I'm going to start moving the actuator. I'm going to stop moving the actuator. So you can actually go actuate this, look under the hood, see if it opens and closes. If you wanted to watch the voltage change on the sensor, you can do this test and have a lab scope hooked up to it at the same time. So you can see the scope voltage go up and down as you're opening and closing the wastegate valve there as well. So a couple different ways you can go about it, and a lot of different functional tests. And as we saw with the code, the manufacturer also wants you to look at data PIDs sometimes as well. So a couple different ways of going about that. As I said before, a lot of the failures are going to be mechanical anyways, because by and large, most of the turbos out there don't have electronic wastegates. They're going to be mechanical. So you're going to see some sort of a mechanical failure before you see an electrical failure on those types. But as we saw in that Santa Fe as well, the number one and number two codes are problems with wastegate solenoid. So it can be either way, I guess. So let's talk about next week. That's it for this week. So let's talk about next week. Air conditioning, operation, and testing. The warmer months are with us in the Northern Hemisphere here. So it is high time to talk more about air conditioning. We're going to talk about the different types of oil and refrigerants and different types of systems and how they work, the underhood mainly area. We did have one on HVAC that talked about the interior of the car mainly. This one's going to be mainly out under the hood, compressor and such, pressure switches and that sort of thing. So same time, same place as always, every Tuesday, 6 to 9 Eastern, snapon.com/OT if you want to watch on Zoom. On YouTube, the first session goes to YouTube at 6 p.m. Eastern. We're doing that right now. So youtube.com/snapon diagnostics. If you're watching on YouTube, we'd greatly appreciate it if you subscribe. Doesn't cost you anything but a click. And then make sure you ring that notification bell as well to make sure you know anytime we go live, because we're going to go live with more things than just this. And we also post more stuff than just live streams and other training content as well. So make sure you subscribe to the channel and we much appreciated. Definitely help us out. And also thanks for the likes on the stream. You can give a thumbs up on the stream. That helps us out as well. And then we have our previous live stream topics if you want to see anything we've done in the past. So there's 42 different episodes up there now. It's in a playlist for live training. Things like ADAS, data bus testing. We did a component testing series last year. So we got all that stuff, body electrical, pressure transducers, etc. So wealth of information out there. And the best part is it's all free. All free. I always say if it's free, it's for me. So we always do a ton of free training. We got more free training coming throughout the year. So definitely take a look at youtube.com/snapon diagnostics to check that out. All right, let's get to questions. But before I do that, I also want to make sure I mention my buddy Al. So Al also does free training for Snap-on, and he does it Mondays, Wednesdays, and Thursdays. So he does it on a different scan tool every night. So Mondays on Apollo, Wednesdays on Zeus, Thursdays on Triton. So if you want your initial training, I want to learn more about what this tool can do, definitely the classes for you. So the first hour on all the classes is going to be roughly the same stuff, just on a different whatever tool he's using that night. So things like let's set up your Wi-Fi. There's a lot of things that require Wi-Fi on a modern vehicle now, all the way through. Let's set you up with your free Snap-on Cloud account, all the way through. Hey, let's walk you through code to completion on Fast Track Intelligent Diagnostics and show how it helps you diagnose cars easier, faster, and all that. That's first hour, and that's pretty much the Apollo class. And then on Wednesday and Thursday, since the Zeus and Triton have lab scope, meter functions, and so on, he takes a 5-minute break after the hour and then goes for another hour on the Zeus and the Triton as well. So definitely worth your time. Al puts a lot of effort into these classes. He's been with us for over 30 years. So definitely a wealth of Snap-on scan tool knowledge. Same time, same place, 5 and 8 Central, 6 and 9 Eastern. snapon.com/OT to register and save your seat for that one. All right, let's go to questions. If you do have questions and you're on Zoom, just use the Q&A function. I'm going to look at YouTube. Looks like we don't have any questions on Zoom at the moment. Let's see. Abel says he actually has a question this time. Thank you for asking a question. Let's see. 5-volt reference 1, 5-volt reference 2, 5-volt reference 3, and 5-volt reference 4. The number one 5-volt, I have 5.02. The sensor is bad. I need to find which sensor is that. That is right. So 5.02 volts on a 5-volt reference signal, I'd say that's probably okay. But if you do have a bad sensor, you need to figure out which circuit it's on. So that'd be leading you to a wiring diagram. So usually on a wiring diagram, when they have multiple 5-volt reference circuits, they'll usually say on the pinout. So it's probably going to be coming. It comes from the ECM. So if you look at the pinout on the ECM on the wiring diagram, it should say where each of the 5-volt references, and then just kind of follow the flow with that. I guess is the best I can tell you. Let's see. Nick says hello from the UK. I know it's pretty late there, so thanks for checking in there. Abel says on Chevy Cruze 2012, no code. So 5.02 volts, the sensor is bad. I'm not really sure what sensor would be bad there. Raymond, hello. Good to see you. And 23 Chichiro, thank you for joining us as well. With that, looks like we cleared the big board. And hopefully you'll join me next week for air conditioning, because it is getting warm. It's getting warm down here, I'll tell you that, my studio. Thank you very much for taking a little bit of time out of your day and spending a little bit of time with us. Hopefully we took away some tips and tricks and tidbits on turbocharger, supercharger, and anything boost related that we talked about. Hopefully we'll see you again, as I said, next week and every Tuesday. Go check out any of the previous recordings if you wish. With that, enjoy the rest of your week. Enjoy your weekend. Mother's Day is coming up in the U.S., so hopefully we'll be able to spend some time with family, and hopefully we'll see you next week. Have a good night. Take care.